All right. Now let's go ahead and start talking about what we're going to cover today. What we're going to do today is we are going to talk about responding to a fryer that is either saying heat failure, ignition failure, or help. They all mean the same thing. Okay, depending on the controller you have, and I'll show you a picture of every one of these control, well, except for the touch screens. But I will send or show you. But depending on the computer, it's going to tell you in different ways, but they all mean the same thing. All right. So if somebody's not muted, go ahead and mute because there's a lot of feedback coming back. I think we just took care of it there. Yeah, it's because it stopped. But anyway, all of these mean the same thing. And what is heat failure? And we're just going to refer to it as heat failure, although it could be help or ignition failure. Heat failure is anything that causes the ignition module not to get a signal back, okay, that keeps the relay, the internal relay in that module energized. Once that relay de-energizes, then it sends a signal back to the controller to give you one of these signals here: help, ignition failure, heat failure. All right, that's it in a nutshell. But just think about it. The reason why we're not getting a signal back to the module could be because we have a bad flame or we don't have a good quality flame. Okay, if that's the case, that could be blower motor. It could be, the gas valve not sending the right pressure. Our gas air mixture is not right, which is a big thing there. It could be. So this really, in a nutshell, this is the correct answer. This is heat failure. But the thing of it is, this could be many, many different things. All right, we could probably make a list of 25 different things that would cause the ignition module not to be getting a signal back that satisfies that module. The problem could be that we're getting a good signal back to the module, and somewhere internally in the module, it's not working. So even though we're getting the right signal, it's not keeping that relay closed. Once that relay de-energizes and opens up, it then stops sending the voltage on through the 24-volt circuit, which we're going to go over that in great detail. But it stops the voltage from getting to the gas valve. That's the end spot. And then it's going to send that voltage back to the controller to give you this signal here. It's going to keep that it's going to stay into ignition failure, help, or heat failure until you shut it off and then turn it back on, which basically reset it. Okay, but that's what heat failure is. Now we got to figure out, what causes, that not to get the signal or the module not to process it right. And that's what we're going to go over now. All right, just to go ahead and show you the controllers on these right here. We have the M3000, which is for the Love Fryer, and the 3000, which is for the Filter Quick. This is the Love Fryer.
You can get out of it and be in your iPhone.
Hey guys, go ahead and stay on mute, okay? Because we got somebody having a conversation there, and it's a lot of feedback. But anyway, this right here is the 3000 controller. This one will say heat failure. This is the FQ3000, which is the Filter Quick. That will say heat failure. The older style fryers, which we still currently make this one here, this fryer here, you can buy one like that. But this is the CM3 controller, CM3.5. All right, this will say help. This one here will say ignition failure. Okay, again, all of them mean the same thing. It means the fryer has locked out. The reason why we chose this issue right here, okay, to be the first course that we did about 4 weeks ago. Now, it's surprising how fast time goes, but we started with this one here is because went to the call center and I asked them, our tech support, what is the #1 thing that you're getting calls on? And it's ignition issues. Whether, I got a fryer that's going into help. I got a fryer going into ignition failure. I got, heat failure. All on these high efficiency gas fryers, whether you have a touch screen, whether you have these controllers with the automatic filtration on them, or you have the simple, standard 855 fryer that doesn't have the automatic filtration in a 50-pound pot, they all heat the same way. When we're talking about gas air mixtures, now when it comes to the controllers and the interface board on the touchscreen fryers, it's a little bit different. The roles there have changed a little bit. But other than that, when we're talking about checking microamps or flame current, when we're talking about that, all of that's the same. Even though we might have a fancy touchscreen controller on there, okay, I mean, as far as the combustion part of it, it's all the same. If we get issues like the fryer is popping or locking out, going into help, we troubleshoot those things the same, okay? And it's very important that people understand that, because We have a lot of changes. As a matter of fact, Roger and I were talking right before we started here about how things are changing so quick, and believe me, they are. I've been here for over 20 years, and it's like, things used to stay stable for a while. We come out with a new piece of equipment, and we would go ahead and use that for a while. Now things are changing very quick, very quick. This fryer right here, okay, that came out in 2009 is now obsolete. Okay, at least domestically. We may sell them overseas, but this fryer right here is not even sold in the United States anymore. All right, and it just came out in 2009. It was still the new love fryer. Okay, that's what we were referring to it as because it seemed like it just got released and it's already now obsolete. So things are changing very quickly, but the reason why I want to emphasize that is when it comes to, some of you guys that's been doing this for a while, 20 years, like me, this here that we've learned 20 years ago is still the same. So when we go out there, we don't have to relearn that. Okay, maybe some of the controls and stuff have changed, but this part that we're going to be talking about today has stayed the same. All right. With that said, and we talked about how many different things, can cause these fryers to go into heat failure. Okay, like I said, we can list 20 different things, but what we need to do is start checking the, some of those things and eliminating them. And like I always tell people, what is the first thing that you want to check? All right, and there is a right answer for this. There is a correct answer, and the correct answer is the easiest to get to. All right. I don't think anybody that's listening on this, and me included, enjoys spending time being in people's way in a store, everybody walking over you, but we've all been there. We all do the same stuff, but nobody enjoys that. So we don't want to stay there any longer than we need to. So when we get there, some of the things that can make these fryers lock out are very, very simple. Okay, no tools required to fix them. One of the things that we can do is just, we can just open the doors of this fryer and we can access a lot of those parts that we would have listed on that list of, 25 different things that would cause this to lock out. And just a little closer view here, we have our drain switch or our drain valve handle, which activates a drain switch. That safety drain switch is there to break the voltage to the gas valve if the drain valve is open. If the drain valve is open, there's no oil in the pot. We don't want the fryer to heat. That's why we have this safety switch. I would hate to see that thousands and tens of, I'm sure it's in the hundreds of thousands of dollars that we have spent closing this drain valve. All right. Even after somebody calls in and we, ask them to check it, as long as there's oil not coming out of the pot, people assume that the drain valve is closed. But in this case here, it's not so much physically closing the drain valve, it's making that micro switch, which I'm going to show you here very next slide. It's making that micro switch. Okay, if that switch isn't closed, we have no voltage going to our gas valve. The gas valve is not going to put gas into the combustion chamber. If we don't have gas or fuel, and if we don't have air and we don't have ignition, we don't have a flame. Those three things we have to have. All right. Right there, the only tools required to check this is just to look at it. Okay, open the doors of the fryer, no tools required there, and then just look at it. Gas valve, we have an on-off switch here, and I'll show you a close-up of that. Never has that ever been an issue up until a few years ago, and I'll explain that when we get to the gas valve. But all this we can look at just by opening the doors. We don't need any tools for that. Our blower motor right here, we can see that the blower motor is running for one. We can make sure that the damper, and I'm going to show you close-ups of this, we can make sure that the damper has not closed itself off, which happens sometimes. They vibrate, that little screw comes loose, that damper closes off. If we don't have air, we don't have a flame. Okay, we need that oxygen as one of our three components to have a flame. And if we don't have it, all right, the flame's going to go away. If we don't have a flame, we don't have a signal, that relay in the module is going to de-energize, and that's when the fryer is locked out. The other thing that we can use in here is we can look at these in these sight glasses just to see if we have a flame. When we look in that sight glass and determine whether we have a flame or we don't have a flame, we just cut our troubleshooting in half. If we have a flame in there, we don't have to go and check voltage at the gas valve. We don't have to ohm out the high limit. We don't have to ohm out the drain switch. We know that we got voltage to the gas valve just because we have a flame. Otherwise, we wouldn't have gas. All right, that valve would not be open, okay, to let the gas pass through, okay, if it didn't have the voltage. We know that we have some air, Okay, if the flame is on, we have some air. Now, if the blower doesn't come on, you'll get a pop, but you won't have a flame stay on steady. The burners don't work that way. It has to have that constant flow of air. So we know we have some air going in there. Now, is our gas air mixture on? Maybe not. All right. If we have a flame in there, but yet it's still locking out, our issue is we're not getting a signal that's good enough back to the ignition module. Now, what signal is good enough? When we get to the modules, I'll show you the range that we have to have on each module. If we're not getting a good signal back there, what we have to do then is we need to check to see what our signal is going back to the module. On the doors of the fryers, now this fryer here was in manufacturing, so it wasn't completed. There'll be a lot more stickers put on these doors. Okay, you know, here it's just got the data plate on there. There'll be another sticker on there that has an orange and a blue circle. Okay, and what that sticker does is it talks about what color flame or what color this flame should be inside this combustion chamber. In our fryers, on our high efficiency gas fryers, that flame has got to be an infrared color, and I'm going to show you that in 2 slides. I'm going to show you what color that flame should be. If it's not, we're not producing the signal, okay, to our mod or to send back to our modules to keep this thing going, okay. On a manager level, okay, I tell them we have to go out and do training for managers and things like that, and you know, and say, hey, here's some things that you can do to, you know, eliminate having to have service calls. And you know, I'll tell them if you adjust the damper on this blower motor, and if your flame was blue and now you have made it orange, chances are you fixed your problem. As a technician, if you're getting paid to go out there as a professional technician, okay, we don't want to use this to set our blower motor. We want to take out our meter, put it on microamps, and check the microamps to set it. It's a much more accurate way of doing it. Okay, on a manager level, that's fine. You have nothing to lose. Okay, but as a technician, we need to see where we started with our microamps and then set it accordingly into the range that we need. And if we do that and we see that number go up, most likely we fixed our problem. All right, just looking at the color, that's not good. And you know, a manager should have already done that at their level. If we're calling a technician out, we had to take the next step. We need to have definite numbers, okay, to look at. You know, and I said it a million times. You know, there's a difference between a maintenance person and a technician is we have meters and we know how to use them. Okay, otherwise we're just a maintenance person. Anybody can go out there and you know and just start messing with this thing to change the color a little bit, but a technician is going to want to know exactly what the change that was made. All right, so that way we make sure that we fix the problem. We don't have that dreaded callback. All right, but those are the things. Right here's the igniter, which has the flame sensor. I can't tell you how many times I've gone out and just seen this wire pulled off. That is the wire that sends the signal back to the module. If that wire is not in place, even though it's something very simple, we got a spade terminal that came off, that could cause the problem there. We're not getting the signal back. That flame will come on. It could be the prettiest flame in the world, but if we're not reporting that back to the module to satisfy that module, all right, that's going to be a problem. Here's the drain valve handle. You reach in there, somebody grabs a handful of that wire, they pull it off, all right, could be an issue. This right here is the igniter wire. If those igniter wires are broken down because of the heat and the oil that gets on them and the insulation on here breaks down, if we get another path to ground, we don't need that voltage to get to the igniter to cause the spark that we need for the ignition. All right, we'll just be sparking somewhere else. It's the same as in a car. You open a hood and it's dark outside and you see sparks from your igniter wires and stuff somewhere else, that just means that it's not sparking where it needs to be. All right, that's not as big a problem as now as it used to be. But I remember first cars I had, that was always an issue. Everybody was always making new wires and stuff. That was just part of a tune-up. But anyway, flame sensor wire, this is the igniter wire. Either one of those could be an issue. If this wire here gets shorted out, that means that it's not going to send that voltage into the flame sensor to travel through the flame. It's just going to take the path of least resistance. It's going to send a signal back to the module, but it's not going to be one that the module will recognize, and if it doesn't recognize it, it will lock it out. Okay? All of this right here, no tools required to look at any of this stuff right here. All right? All we got to do is open the door. And already, just by doing that, shutting the fryer off, resetting it, and getting it to light again, we've already just, at a minimum, cut our troubleshooting in half. All right? And if you reach in there and you open the drain valve a little bit and you hear a click, and then you close it and you hear a click, and now you turn it on, you got a flame in there, shoot, you've already fixed your problem. All right. Unfortunately, we have spent a lot of money having people go out to look at a fryer because there's a problem and just have a simple issue like this. All right. This right here is the drain switch that I'm talking about. All right. Again, no tools required to see if we're making that switch. Sometimes these cams and stuff, that little tab on here, just wear out. Electrically, you can't check it visually. You would need a meter to do that. But I mean, most of the time, the issue that we have is this valve is just not closed enough to make that switch. And again, that's going to break the voltage to the gas valve. This is the color that you want to see inside those sight glasses, a nice bright orange. This can be very confusing sometimes for people because most people relate, you know, the color of the flame from natural gas is blue. There's even a blue flame award that, you know, natural gas companies or gas companies give out, okay, for innovations and new ideas or whatever to make equipment more efficient. Our burners create an infrared color because of the fact that we have that air blow in there. We have that damper on that blower motor, and it's just like, you know, a torch, you know, a cutting torch. You know, when you first light the gas, you know, that flame is real hazy. This right here is actually a mock-up, okay? This is something that the burner is just sitting on a metal roll-around cart. So I can actually light this thing, okay, and not have air going into it. You know, I can override the flame sensors and stuff and just put gas into it. All right, it's not, you know, I mean, those flames are not very hot, just like a torch. If you just turn on the acetylene and light that, that torch isn't very hot. You know, you got all that soot coming off the end of the unburned gas. When we put the air to this and then we set the air properly, just like you would on, you know, the oxygen for a cutting torch, now that flame on that torch or on this becomes extremely hot. When this mock-up is on, there's two burners sitting side by side. You can't stand looking at that within 10 feet of it. It gets that hot. You can feel the oil on your face burning. All right, these things get extremely hot. This is the hands down most efficient gas fryer there is. At least one that once you get it into the field doesn't have. We have, you know, other types of fryers that are efficient, but in order to make them work properly, you know, I mean, there's a lot of tweaking that needs to be done, and maybe the efficiency drops down. These, no, you can put them in any environment, and you can adjust that damper to, accommodate for lack of makeup air or whatever. But these things are extremely efficient. These fryers came out in 1983, 84 time frame, and even with all the attempts, you know, that we've made in the 20 years that I've been here, there's nothing to replace it. That's why we still keep going on with the same platform. These things have been out for almost 40 years, okay, and they're still relevant. It's still the, you know, the platform for the heating that we go with now, and I don't think there's any looking at changing any of it. Okay, maybe some of the components like the blower motor will have one that you can electrically adjust instead of having that mechanical damper. But yeah, this platform we're going to have forever. So knowing this is very important. That's why we made this the first topic that we go over. One other thing that I like to point out here on this slide, do you see how hot those igniters are? This right here is the flame sensor, okay? That flame sensor, we need to have it parallel in there. I mean, we can't go in there and measure anything because it's sealed combustion chamber, but we have to have it parallel with that burner. If we get it too close to the burner or too far away from the burner, either one of those is going to affect the signal that goes back to the module. So we need to have it parallel. Having these igniters clean and without any defects on them is real important. Like this right here being the flame sensor. All right, if we have a lot of carbon buildup, if somebody has used a means of cleaning them that's not approved, like emery cloth or taking a pocket knife. We used to have a guy that used to work here. You know, this is how things, you know, we learn all the time. But during the time when I first went through here, it's like, oh yeah, you can take out, you know, he'd take out his pocket knife and show you how he would just scrape these off and how shiny he could get it. The only thing is all those places where you dig into that metal, okay, is now a spot where it could bend. I don't know if anybody's, you know, seen that show Forged in Fire. I enjoy it. I just like that kind of stuff. But, you know, you see, and one of the things that they have an issue with is when the metal gets red hot, okay, just like this, sometimes it'll warp, okay, or start to move. Same thing can happen here. If we have carbon buildup on these, all right, that could be an issue because that part's going to be insulated, and that metal is going to move at different rates, and that's what causes the metal to move. All right. So we want to avoid that. The only time that you should have carbon buildup here is when we have an issue that we're getting oil into the combustion chamber. Okay, for whatever reason. Probably not going to be a leaking fry pot because I'm going to go on record right now and say our fry pots don't leak anymore. All right, all the ones that we get back now is because of oil migration. The very, very few that are possible leaks, okay, and then they're not the high efficiency one, maybe tube fryers or stuff. I don't keep up with those as much. But the thing of it is our fry pots back in 2000, we had a change in how they're made, and our fry pots don't leak. It's probably oil migration. That gets into the combustion chamber. These igniters get very hot. That new zero trans fat oil sticks to anything that's hot. And if we get carbon buildup on there, we have a different issue. I tell technicians all the time, if you're out there and the problem that you're out there is because these igniters were so bad that the fryer was not working, those igniters need to be changed. All right. Instead of cleaning them, they need to be changed. And I know I don't want to come across like a parts changer, but in this case here, it's like a spark plug. You wouldn't take a car or a mower or anything like that in to get fixed, and the people there would just take the spark plug out and clean it. No, it would be replaced. This is the same deal. Unfortunately, these spark plugs are a little bit more than your average spark plug you put in a combustion motor, but nonetheless, if they're to that point, it's time to be changed. All right, blower motor. The blower motor is very simple. You got a turbine inside. That turbine spins, pushes air out. As long as you got air, okay, being sucked into this right here, if you put your hand up there, the blower motor's working. Now, the thing of it is, though, as they get older, this motor, it's got brushes in it, and things like that that'll get glazed over with the oil and stuff. That the new oil, that zero trans fat oil, has a characteristic they call shellacking. Anybody that remembers back when we were having all the problems with the pumps when they came out with that, that's because of the shellacking. Okay, that oil actually becomes kind of like a crystal. Okay, and it gets very, heavy. Well, if that gets on the brushes and stuff, that's going to cause that motor to work harder, which is going to draw more amperage. Okay, if that happens, it starts to wear on the relay that sends the voltage down to turn this on. So again, like the igniters, if you're out there and that blower motor, and this, believe me, this is not bad. That's not bad at all. But if you go out there and the blower motor is in such bad condition that you have to take it apart and clean it, I completely recommend that you change out that blower motor. And it's for reasons other than just, this being clean. It's because internally we're probably now drawing more amperage. Now you can do an amp draw on this, and it should be down around 2. There's a fuse that is in line with this. It's a 3 amp fuse. All right, but so I mean the max would be 3, but it should be down around 1.5 to 2. Okay, and you can check it that way. But in this case here, I mean, you could physically look at it and see if that blower motor, and you can, I hate to say it, it's not the most technical. If you smell it and you got that burning ozone, that's because of the amp draw has gone up higher, and that means that motor is pulling more amperage, and it's just wearing on the relay and everything else. If that relay starts to wear out, or this blower motor is slow to react, that results in popping. All right, and popping, or that backfiring, is going to do damage to the burner. If those burners then need to be replaced, this blower motor, I don't know what it costs anymore. We don't sell parts directly from here, so I don't keep up with that as much. But that guarantee that blower motor is not as much as a new burner job or a burner technician, and you're out there, and that blower motor is the cause because of the condition it's in. It needs to be changed. Okay. And if, there's a problem with that and it needs to be justified, I have no problem discussing that. When I meet with groups of managers and stuff, I tell them the same thing. If this blower motor is being kept up, the technician won't be out there working on that fryer because of it. So if they're not going to do it, our option, I don't like to just go out and clean stuff like this. I want to make sure that we got a good component on there. And that blower motor is the #1 cause of popping. So, all right, this is the gas valve. Our gas valves, maximum pressure, 0.5 psi, okay? With the 2-pound pressure systems that a lot of construction companies have gone to, because you can use smaller pipe if you bump up the pressure, and then they have to have it double regulated. I don't have all the ins and outs on that. I know just enough to go ahead and whenever we have an issue, especially if it's a new install and we got problems with multiple gas valves where we got voltage to it, but it's not opening, I guarantee you the problem is we have too much pressure. A lot of times people will think it's like, well, if we get too much pressure, that's just going to blow through the valve. No, more times than not, if you got too much pressure, it puts so much pressure on those diaphragms or whatever it has in there. I don't know if it's actually a diaphragm, but it puts so much pressure on there when you put the voltage to it, it can't open. It's just like a solenoid or anything else. All right. Checking the incoming gas pressure is very important. Okay. We need to make sure that it's not over the half a PSI. Half a PSI is 14 inches. As long as we don't exceed 14 inches, okay, we're okay. All right. And that's natural or propane. The maximum is 14 inches. Okay. And that's why we want to check that. When 2-pound pressure systems first come out, there was a lot of constructions in the early 2000s. We were selling a lot of equipment. That's the first time I dealt with it. All right. And then we started seeing it's like, man, we're changing a lot of gas valves. And come to find out, the issue was we just had too much incoming pressure. Okay. The gas valves do have an on and off switch. Don't overlook that. Okay. Before, when I say before, prior to 3 years ago, this was never an issue. Very, very seldom did you ever have somebody that turned off that valve and they forgot to turn it back on. Obviously, if the valve is off, we're not going to get any gas out of there. We're not going to have a flame. You don't get the signal. All right. There is a chain now that their procedure is when they filter to put the gas valve in the off position. If the person filtering forgets to turn it back on, then obviously we're going to have an issue the next day. So just don't overlook that. It's just we never thought about it before. All right, some of the other components that we have, okay? If we was to lower the controller, we're going to need a 6-in-1 screwdriver to do that. We have some Phillips head screws underneath here. That's on the current one. The older style, we had a couple different bezels, 3 that I know of. Once you lower the bezel down with the Phillips head screws that we have to take out, in behind here, we're going to have 2 1/4-inch self-tapping screws that we have to take out. All right, once you drop that down, this is what you're going to find. Our ignition module is going to be back there. On the newer style fryers, the ignition modules will be hanging down right here. Okay, they'll be right here. Okay, we're going to have the relay that's on the interface board back here and the interface board itself, which is going to have some test points that we can check. All right, the tools that we need to access this right here is a 6-in-1 screwdriver. All right, the interface board, we have some test points on here, which we're going to go over that when we get to the wiring diagram. If we don't get to the wiring diagram, we'll go through the 24-volt diagram, and it has, it'll be labeled J1, J2, J3. That's these test points here. All right, this interface board looks very different from this one. If you were working on this fryer and you determined that this interface board here was bad and you needed a new one, this is the board that you would get. This board has all the relay sockets on it. So if you have a full pot or a full pot fryer, we would just use this right here. If it's a split pot fryer, we're going to need both of these. If it has basket lifts, you're going to need both of these. All right. And if you go through the Love Fryer course, you'll realize that on McDonald's Love Fryers, we use these relays for a safety sensor that we have in there, the OIB. If you have a fryer that has 2 modules on it, you'll need both of these harnesses. If it's a current production H55 fryer, it's only going to have 1 module because we have those dual Honeywell modules that we use. All right, so this board here will work in any application. How do we access that board? Lower down the controller. All right, the relay, obviously this relay plays a very important part because these 2 pieces of metal right here touching together, okay, is what gets this fryer to come on. It sends voltage to the ignition modules, which ends up down to the gas valve. That's the 24 volts AC. We're going to walk through that whole circuit. It also has 120 volts DC or AC that goes down to the blower motor. Gas and air are 2 of the things that we need to have a flame. If these contacts start to go bad, okay, in which that when they go bad, a bad connection, it's going to create heat there because of the added resistance. All right, when they go bad and we don't get enough voltage onto that blower motor and it doesn't come on quick enough, that's when backfiring starts. So this relay right here is very important. If somebody was to ask you how often it should be changed, my answer is always every year. All right. After the fryer is a couple years old, it needs to be changed every year. All right. Because after it's a few years old, everything else is getting older, works a little bit harder, which makes this work a little bit harder. Even if you just left it at, every other year. But I don't think that the cost of this relay, that is overkill because of the fact of the damage that a bad relay can do. If the blower doesn't come on and the fryer continues to pop and those burners go bad, all right, and there are times where oil migration is so bad that those burners, you can't get them out because of all the oil built up around them. At that point, that requires a new fry pot, all because these contacts here wasn't sending enough voltage down to the blower motor. All right. If you look at this relay and you see any signs of soot, if you see any pitting in the plastic, if you see any visual signs that those contacts are, all pitted up and stuff, then that relay needs to be changed. There's no other troubleshooting involved. We switched relays to a bigger relay. It's a 10 amp relay now versus 7, because when we were using the capable control ignition modules, they were pulling more amperage, so we had to have a bigger relay. All right. Ignition modules. I'm going to go through this fairly quick. We've had several different ignition modules. We had a Honeywell module that we started with back in 1984. All right. We used those up until 2000. Then Honeywell said, hey, we have this different module. One, the lockout's a lot lower, which that's really not a benefit for us. It helps with intermittent problems, but we still need to run our modules or set our burners to produce this amount of microamps, which is well above the lockout. But we want this range because if we're below that or above it even, all right, that's not going to give us the optimum flame that we need. Okay, the best flame, the nice bright orange flame that we're looking for, okay, is going to produce a signal of 2.5 to 3.5 microamps using this module, and that's based on the voltage that leaves this module and goes down. I've never successfully been able to measure that voltage. Honeywell did give out some numbers. I never go over them. But anyway, obviously, in order to make current, we have to have voltage. So this sends out voltage. It travels through the flame, which I'm going to show you here in a second. And we need it to produce this. Currently, H55 fryers are leaving equipped with the Honeywell modules. We switched to capable control modules back in 2014. As far as I know, we're not using them on anything. They're still available at some, because of the fact that, people had stock inventory of them, and they weren't all an issue. We had an issue with these modules between 2014 and 2015. Primarily between June of 2015 and November of 2015, the modules that we were getting at that time were all set too low, okay? Meaning the spark wasn't hot enough, and it was causing a lot of intermittent problems, popping and things like that. We have since decided to go with a different module, so we're not using capable controls, but they weren't bad, so we didn't, quarantine all of them. So you still may see some of these pop up, but we decided not to use these in manufacturing anymore. Is there a point where we may need them? It could be, but yeah, as a rule, we're not using these. And it was only because there was just certain things that they may not have worked out well with our equipment. But we did use these for a time. And if you run across a fryer that has these, don't automatically assume that the modules are bad. I mean, we got a lot of them out there. We stopped using them, 3 years ago. So if they're still out there, they're at least 3 years old. So, But anyway, this is the setting that you're going to have on this. This is the lockout that you're going to have on those. All right, the module that we went with now, that all 30-pound fryers, Love fryers, touchscreen fryers, filter quick fryers are going to have on them. And actually, I just lied to you because we don't make Love fryers anymore, the traditional ones. But all the fryers that we sell now, okay, the 30-pound platform is going to have these modules on it. Are there going to be some exceptions? Sure, we didn't have these, the Honeywells. You can replace one of these modules with a single Honeywell module. This is a double Honeywell module, okay, meaning that it can control 2 burners. It has a flame sensor that you can, 2 of them, so you can have them on each side. If you have a split pot, or if you were using one of these, you have to have 2 separate modules. Honeywell makes one like that, okay, and we use it on the H50 split pots. We use that, all right, but you could have like one Fenwall on one side and a Honeywell on the other. There's instruction sheets on how to do all that. Obviously, if you're taking a Honeywell out and putting this one on, there is a kit number. And I thought for sure I put that on this slide, but I didn't. There is a kit number that I recommend that you use, okay, or stock that one, because if you have this in the kit form, it has instructions, it has the harnesses, you can put this in place of any other module, all right? But anyway, then that's the Fenwall. All right, this right here is how the inside of that module works. This is the relay that I was talking about. The fryer calls for heat, which that is another course that we're going to have tomorrow if you guys are interested in listening in on that. When the fryer calls for heat, that means that the relay that's on the interface board gets energized. That 24 volts AC goes into the module. It drops down to the coil of that relay, which means it pulls in that relay. That relay is then going to send the voltage out of the module, back onto the interface board, over to the left-hand module, back onto the interface board, through the high limit, through the drain switch, and then down to the gas valve. But this relay here is what's going to send it on to the next step. That relay is going to stay closed as long as we're getting a signal back here that this module likes, and depending on which module, okay, is going to depend on the signal that it's looking for. All right, but it's going to look for a signal, and as long as we give it that signal, that relay is going to stay pulled in, and our fryer is going to continue to run. If we lose that signal, we are going to try, the module will spark for 4 seconds, okay? If that signal comes back in that 4 seconds, what happens is the module assumes that it lost the flame, and it knows how to get the flame back as the spark. So it's going to spark for 4 seconds. If we get the flame back within 4 seconds, all right, everything is just going to keep on working the way it was. If we go over 4 seconds, if this module loses a signal for 4 seconds, okay, then that's when the relay is going to de-energize, and that's when we say the fryer has locked out, or the module has locked out. It is going to stay in that position until you come in, shut the fryer off, take the voltage away from, take the 24 volts AC away from the module, and then when you turn it back on, then it's going to start the process again. That module will stay locked out, though, until this voltage goes away. And unless you're, electrically inclined to these and know which wire to pull off, which isn't that hard, but, as far as an end user, what they would do is shut it off, that relay de-energizes, and then you can turn it back on and it'll try again. But whenever this has voltage going into that module and that relay is de-energized, that's when the fryer is locked out, okay? And it's going to lock out anytime this module does not see this signal that, a good enough signal for more than 4 seconds, all right? I could take that wire and take it off for 3 seconds, put it back on, take it off for 3 seconds, put it back on. I could do that all day long if I wanted to, if I didn't have anything better to do, and it would never lock out. It's not until it goes over 4 seconds, all right? But this is how the modules work inside. All of them, no matter what brand, they all have the same thing. If you use to pop one off, you see that little black relay, just like the ones we have in our electric interface boards, and that relay right there is what's going to keep that fryer from either heating or going to go into the lockout mode. All right, flame rectification. How that works is we supply voltage to our flame sensor. I showed you, on our igniter where the flame sensor is. All it is a piece of metal with voltage applied to it. We have voltage applied to that flame sensor, okay? That voltage, like any other voltage, is looking for a path to ground, okay? The only path that we want this to have is through the flame. The flame is actually conductive, okay? Just like water or, anything else, but the flame is actually conductive where voltage can flow through there looking for a ground. Once it gets the ground, okay, we have a complete circuit. When you have a complete circuit, you have current flow. Current is measured in amperage, all right? That's where the microamps come from. We have very, very low current, okay, produced by this circuit right here. That's why it's measured in microamps. Micro is 1/1,000,000th of an amp. It's a very, very small amount, okay? So whenever we're looking or checking for microamps or checking for flame current here, we have to have a meter that will read microamps, not MA, but UA, the backwards UA And that's microamps. You know, I'm not a big fan of Harbor Freight. Hopefully nobody's on here that works at Harbor Freight, but you know, I mean, you get what you pay for. But they had those little red meters that you can get for free if you cut the coupon. Those are great for reading microamps, and you can get 2 of them for nothing. But I use those when I like travel. I'll have them with me because I can pick them up. Even if you got to pay full price, they're like $6.99. But reading microamps, they work really well. All right. You when you read it, it's going to be DC microamps, okay? Because not only does that flame create a path to ground, which is not going to be a dead short to ground, okay? It's like a resistor. But anyway, it not only is going to create a path to ground, it's also going to take that AC voltage and rectify it to DC voltage. That's what the ignition module is looking for. It knows, because we could have another path to ground. You know, if we had a resistor of some kind in here, or, you know, some insulation that's partially broke down, the porcelain around this igniter is partially broke down, where you don't have a direct path to ground, but you do have a path, we have a circuit. You know, if you got a resistor there, that's the load, or a resistance, that's the load. If we got a ground, we got a circuit. The only thing is we don't rectify that current. So the module is looking for 2 things. It's looking for current in a certain amount, okay? And it's also looking to see that that AC voltage has gotten rectified to DC. If we was to send a signal back, if we was just to take a resistor and we got our current in the range that we needed, but it was AC, that module would still lock out. It could be right in the center of that 2.5 to 3.5 microamps. It could be right at 3 steady. But if it wasn't rectified to DC, the module would still lock out. So environmental issues can come into play here. If you have moisture or things like that, because we used to make pasta cookers that use this same thing, same module, same type of burners, but they were open and there was steam in the environment, we would have intermittent locking out because of the fact that we had a direct path to ground without it having to go through the flame. And if the modules pick up an AC signal, okay, it's going to lock out. All right, so making sure all the insulation and stuff like this is good so we don't have a short to ground is very important for that reason. But that's flame rectification right here. Anybody that's taken the Cefesa gas course, and some of you guys on here may teach the course, but anyway, there's a lot more involved in that. But as far as the way our equipment works, this is it in a nutshell right here, okay? This here is how you check it. You can either check it at the module. Again, keep in mind that the new, or the 30-pound fryers, the modules hang underneath. Okay, they'd be down here. So you open the door and there's a cover on them. All right, or you can check it down at the igniter. What's the best place to check it? Whichever one's easiest to get to. Okay, on these type of fryers, I like doing it here because, you know, this creates a little platform here for you where you can go ahead and hook your meter up. On the other ones with them hanging down below, and especially with the Fenwell modules, yeah, they're a lot harder to get to. Okay, and then the Fenwell modules don't have a, you know, your leads and stuff on there because of the connector they have on them are totally different. All right, high limit is a safety that all our fryers have to have. This is a thermostat that is set at 1 temperature. That temperature is at 425 degrees. Our fryers are designed, now I don't know, some of the newer controllers may be able to set it higher, but it used to be our fryers, the maximum temperature you could set them at was 375. Okay, anything over there, you know, oil gets a little volatile and, you know, we don't need to go over that. This here is set at 425 degrees. If that oil hits 425, we know that there's a problem. These fryers here, high efficiency gas fryers, it is extremely rare that you're going to find one of these that overheats because too many things have to fail for them to overheat. All right, we got 2 sets of contacts in the relay. That relay would have to both sets would have to fuse together, which I got to be honest with you, it may have happened in the 20 years I've been here, but I can't remember. But it is very unlikely that these things are going to just run away with heat. Now, is it possible that they overshoot temperature a little bit? Yeah, that's fine. You know, there's things in the controller that would cause that. But yeah, it's very unlikely that'll happen. But if it does, we got a high limit in here that's going to open. When it opens, it breaks the voltage to the gas valve. It's going to shut the fryer off. All right. Now that we've gone through all our components, let's go ahead and put them all together and see how this plays out. All right. What we're going to do is we're going to talk about the 24-volt circuit because this is what's got the modules in it and the gas valves and all the safeties in it. So whenever you're going out there to work on a fryer that's in heat failure, most likely it's going to be in this circuit here. Okay, so that's what we're going to talk about. We need our 24 volts. We need to get that. We hadn't talked about that yet. That is located in the back of the fryer in the transformer box. That 24 volts is going to come up by a harness to the interface board, and it's going to go to J3 pin 8. J3 are those little solder points that I pointed out when I was showing you the interface board. So they're labeled at 1 through 12. So if you go to pin 8, and all this 24 volts is referenced to ground. So if you go from pin 8 to ground, you should have 24 volts AC. Here's a little tip for you. Anybody that does technical support, like over the phone, like you have a technician out on site, and if you say, I need you to check for voltage at pin 8 of J3, and they tell you got exactly 24 volts, ask them to check it again, because you're never going to get exactly 24 volts. That's a good way for us, because we have indicator lights on here, the LEDs that come up, and I think I mentioned it. If I didn't, I apologize. When we were at the interface board, as a matter of fact, I'll go back to that, just be a second. But on the interface board, we have indicator lights. They're little green ones now, like D6 here, that's 12 volts AC coming to the board. D5 would be if we had voltage coming out of our left-hand module back onto the board. But these lights, and we have a D3 that is located right here, which is our 24-volt light. A lot of times people see that light on and say, oh, yeah, we got 24 volts. All right, how many volts do you have coming to the board on pin 8? Oh, 24 volts because of this light. This light is a good indicator, okay? I have nothing against those lights, but the thing of it is, and I've said this ever since I started here, those are just an indicator light. It does not quantify how much voltage you have. You can never condemn a part using these lights, okay? If we have this light on here, but our gas valve doesn't open, you know, we can't say, oh, we got a bad high limit or a bad drain switch, or we just have a bad gas valve. No, we got to put a meter on there. And I'll get to that here in just a second. But yeah, these lights are a good indicator, but you cannot condemn a part just using those lights. All right, so 24 volts comes up, it goes through a fuse because that 24 volt circuit is fused. All right, the LED 3 comes on, indicating that we have voltage on that circuit. Then it comes over here and sits at the relay. Where is this relay located? What tools do we need to access it? We need a 6-in-1 screwdriver. Lower the controller down. You'll be looking at the interface board. That relay plugs onto the interface board. All right, we've already talked about that. All right, that voltage comes up to here. When the fryer calls for heat, okay, and if you want to know how that happens, tune in tomorrow at, I don't know what time, I think 9 o'clock Central Time. Yeah, 10 Eastern Time, 9 Central. We'll go over all that. Anything you want to know about how to energize that relay, we'll go over then. But when that relay, or when the fryer does call for heat and this relay energizes and closes, we have our 24 volts illuminates LED 4, indicating that relay closed. All right, that voltage then leaves the interface board, goes to the module. Okay, and if we only have one module, it just goes to the right, but we're going to go through this one. Because if you know this, the other one's easy. It's only got one module. But we go through the right-hand module. It goes through the relay inside that module, okay, at least for 4 seconds. Even if the flame doesn't come on, it's going to go there for at least 4 seconds. All right, it then goes back onto the interface board, okay, on these terminals here. Then those are labeled on the interface board. And it goes back onto the interface board. LED 2 comes on to say that that has happened. All right, then it goes through the interface board over to the left-hand module. It goes through the relay in the left-hand module, back onto the interface board. LED 5 is going to come on to let us know that. All right, then that voltage is going to go to pin 9 of J3. Okay, so just below, I think below or above, but right next to pin 8 on J3, the high limit plugs into pin 9 of that plug. On the back, there's a 12-pin plug. All right. Pin number 9 is where the high limit plugs into. In series with that pin 9, it goes to the drain switch, and then from the drain switch, it goes to the gas valve. All right. Now, the drain switch is only going to be on fryers that have a filter system on. This little note right here, if you got a fryer, the newer style 30-pound fryer that has an OIB, the oil back sensor, okay, the contacts of the relay that controls is going to be right here instead of the drain switch, because you don't have a drain switch, because on the automatic filtering fryers it does that automatically. But there is a safety that we put in series with this to stop the voltage to the gas valve. All right, and if you want to learn about that, we went over that for the last 2 days, and we're going to go over that again probably the week after next. All right, but anyway, that's from where the 24 volt starts till it ends up at the gas valve. That's how it works. It goes through all these components. All right, that's normal operation. These contacts close, and that 24 volts goes through all these sets of contacts. You got a set of contacts here, set of contacts here, here on the drain switch. So all of those switches have to be in place. It's just one big long series circuit. All right. So let's go ahead and see how a failure is going to affect this whole thing and how we can see that. Let's say, okay, I come in and I go over to the flame sensor wire down at the igniter. I got the computer drop down and I'm looking at the module. I'm down at the igniter. I see that little white wire there. I walk in, I go to filter the fryer, I grab that wire by accident, and I pull the wire out of the spade terminal. It was running just fine, okay? And so anyway, when I pull that wire out, that signal goes away. What does that module do? It starts to spark. Once it loses that signal, it says, hey, we must have lost the flame because I don't have a signal anymore. What do I do to get that flame back? Well, I know my job is to go ahead and create the voltage to go down to the igniter to spark. So it's going to start to spark for 4 seconds. Okay, it's sparking. All right, we get to 4 seconds, like, hey, I still don't have the signal back. All right, what it's going to do then is that relay inside that module is going to open up. Is going to open up. Once it opens up, everything from here on down goes away. All right, so this, all of these lights, they both go out. All the voltage that goes through that module, that's going to stop. That module is just going to, just like it reached set temp and that relay open, that module is going to deactivate. So everything from here on down goes away. So that means both these two lights have gone out. So if the right-hand module locks out, LED 2 and LED 5 are going to go out at the exact same time. All right. Let's say that I reached in there and I grabbed the flame sensor wire from the left-hand module, which is more likely because of where the handle is mounted. On some, we've had so many different designs on drain valve handles. But anyway, so I go in there and I reach in and I grab the wire here and I accidentally pull that spade terminal either off of there, which I doubt. It's going to come out of the wire is going to come off of the actual end before it comes off of that spade. They're so tight on there. But anyway, so I go in there and I pull the flame sensor wire off of here, okay? What is that module going to do? It's going to start to spark, trying to get that signal back, all right, because it assumes the flame went out. So this thing is going to spark for 4 seconds. Since I have that wire broke and I can't make that repair in 4 seconds, okay, we're going to exceed the 4 seconds. That module is going to lock out, which means the relay inside here is going to open up. When that relay opens up, everything from here on down goes away, okay? So LED 5 goes off. Up until that point, the right-hand module didn't have a clue that anything was going on, okay? I pulled the wire off the left module. Nothing happened to the right. Everything was going fine. Once this relay opens up, though, all right, then everything from here on down goes away. That means the gas valve is closed. What has that done to the burner on the right-hand side? It shut it off. Okay, so now it lost its signal because of the fact that the flame went out. So this one here locked out and LED 5 went off. At that point, this one here says, hey, we need to try to, we're going to spark, or send, the signal down to get the ignition, trying to get that signal back. Well, it's going to spark for 4 seconds. It's never going to get that signal back because it doesn't have any gas. So after 4 seconds, this light goes out. So if LED 5 goes out and about 4 seconds later LED 2 goes out, that indicates that the left-hand side has locked out first. So that scenario would be you come in, all right, you know that the fryer is locking out. It's going into ignition failure, help, or heat failure. You come in, you look in those sight glasses, and you see that we do have a flame. Right away, you're saying, okay, we got a flame, but for whatever reason, it's not good enough, or we're not sending a good enough signal back to that module, or the module's not processing it correctly, all right? So I need to check our microamps. So which side do we want to check first? We lower the computer down. We look at these lights. LED 5 went off, and 4 seconds later, LED 2 went off. We're going to be checking the left-hand side. If both modules went, or both lights went out at the same time, we're going to start on the right-hand side. So we're in the store for less than 5 minutes, and already we got our first place to go check. All right. So like I said, whenever we're troubleshooting these, just by, accessing the easiest stuff first, is going to lead us, on a path. If we went in and we looked in the sight glass and there was no flame, and we looked down, it's like, oh, they forgot to close the drain valve. All right. Or, you may look in the pot and find that the high limits broke. Not so much anymore, but back in the days when they had hard shortening, they would drop those blocks on there and bam, this was the first thing it would hit. And then those high limits would break over. And then obviously if the high limits broke and you can't get voltage through there, that cuts off the gas valve. Again, the right answer is, what do I check first? The easiest thing to get to, okay? Because we want to minimize how much time we have in the store as much as possible. Tomorrow, okay, what we just talked about now is this blue circuit, that optional air switch that's only in fryers over in Europe, okay, or overseas, CE countries. But anyway, so we don't worry about that. But anyway, this is the circuit we just gone over. Here's LED or J3 pin number 8, 24 volts comes in. There's LED 3. Here's our heat relay. This here is something we'll talk about tomorrow. This is just the blower. I mean, when it closes the switch, the blower comes on. But anyway, it goes through the heat relay, goes off, the LED 4 comes on, goes into our right-hand module, comes back onto the board. LED 2 illuminates, goes into the left-hand module. All right, goes through the relay there, comes back onto the board. Then LED 5 comes on up here. Pin 9 of J3 is where the high limit plugs into. That high limit then goes down to the drain switch. Then the voltage goes to the gas valve. That blue part of this wiring diagram right here is this right here. Okay, I just like this because it's easier to show it, but then at the end, then we go over this. This wiring diagram is in our tech reference manual that you can get online. Okay, somebody had asked me about where to get it online yesterday, email. I'm going to send you a link for that. But if you go onto our website, frymaster.com, go to service and then literature, and Roger, correct me if I'm wrong. Yeah, you go to literature and then just go to the tech reference manual. And then that's just a, what are we, 100 pages or so? But it's just a down and dirty, a lot of diagrams and stuff like that. We get a lot of good feedback from our technicians about that. There's some charts in there, probe resistance and things like that. And then it's also got a little bit of the theory too of how this stuff works. But it's a good book. But anyway, those wiring diagrams, these wiring diagrams here are all in that book. Tomorrow, for you guys that tune in, we're going to be talking about the probe circuit and how this computer in here works and all of that stuff. Basically, what it takes to get these two pieces of metal to touch together right here.